What you are seeing here today is an opportunity for the children to take materials from kits and have experiments for a whole marking period. The kits do provide the students with the opportunity to see a difference from experiments, how things don't just happen. Variables make a difference. How they do an experiment makes a difference, and how they record things. So what you do with a kit is ask the child to become a scientist. And once they are a scientist, they have to be able to identify what they're going to do. They're going to have to be able to observe it. They are going to have to be able to write about it. And then they're going to look at it and say, did it do what I expected, or did I get a different ending? And if I did, why? So all these different strategies that we hope a child would understand about science, instead of telling them or making them write it in a notebook, they experience it and they can share it with each other, what they're doing.
The Science Committee discussed many of the options and decided that the kits were a better way to get the children to do more hands-on learning, because research has proven that the hands-on learning helps a child acquire the knowledge much better than just reading out of a book.
In order to ensure that this new approach and this hands-on discovery-based science program was implemented correctly, the science teachers and all of the teachers had to be trained intensively on the program. So each teacher in each grade level was sent to a full-day training in order to make sure that they were prepared to implement this program. We're very fortunate that this hands-on discovery-based science program that we're using allows kindergarten through 5th to experience science in a student-centered, hands-on way. So whether it's the kindergartners doing balls and motion, or these 4th grade students working with circuits and electricity, no matter what the activity, the students are given a real, authentic, hands-on approach.
Children are given challenges, and it's almost a puzzle, a game, and they come up with the concepts all on their own. They're guided through this by the teachers, but in the long run, they develop their concepts themselves, and they love it. They just love it. And everyone is successful because there's something for everyone to do. The child who is a visual learner can learn, the child who's an auditory learner can learn, and the child who's a kinesthetic learner absolutely does a wonderful job with this.
People have been using them for quite a few years in other schools and in this school, and obtained the kits through grants, and saw a difference in the achievement levels of all the students across the board, not just your higher achievers or your low achievers. Everybody seemed to do well. What's interesting about these kits is the assessment, because we do a lot of performance assessments. So we watch what they do, and we use rubrics and what we expect of them, and they definitely excel at it because they're able to act out what they learned rather than write down what they learned. And their retention is very, very good because, you know, they're physically doing things, and that also helps them to remember and to make it real for them and to internalize the learning.
Instead of a written paper and pencil test, we used an authentic assessment. The children were given specific guidelines, 4 guidelines. They were told that they were to build a house with minimum of 4 rooms. They had to have 1 light in each room. They had to hide the wires and hide the batteries. And they did it in teams of 2. And they were to use electric circuits, which is the name of the unit, to build their houses. Each room has a switch so the light can be turned on and off. They just worked for 2 weeks on this, and I would say about an hour a day for 2 weeks. And the results are all over the room. They learned a lot, and they also learned not only just about the circuits, but how to problem solve. It's an extremely important component to all of these kits is the problem solving. Many of the lights wouldn't work, and they had to go back and figure out why could be as simple as the battery was in the wrong direction. But they had to do their own troubleshooting and figure out why they couldn't get their lights to work, why their switches wouldn't work. So all of the children learned not only about electric circuits, but how to think and do problem solving.
The kids are very excited to use these kits. Coming into this, they hardly knew anything about electricity. They have learned so much. They know about electrical circuits. They're using their science vocabulary. They love doing the hands-on and discovery-based experiments. They create light, and putting it together, they can see their experiments right away. The light bulb will light, and they just love every aspect of this unit. When I walk around to see the groups, they use their science vocabulary. They know the definition of circuits, conductors, insulators, and they're using it on a regular basis. It's coming right from their mouth, so I can tell that they're learning from this.
We want these children to become scientists. We want them to become mathematicians. We want these children to have a love of these subjects. And if they do, they will follow them in their older grades. That's our purpose for this, and we hope that when they come home to you, they share with you their excitement for science, and you at home can work with them in ways to reinforce what we are doing here at school.
The traditional approach, which is reading a book and maybe doing an experiment, or maybe even just watching a teacher do an experiment, the children watch thinking going on as opposed to actually doing the thinking themselves. They would read, they would memorize, but there was no internalizing of the materials. They didn't own it. There was no ownership to the problems. All the answers were in the books.
Although we've adopted these science kits and we're dedicated to the hands-on approach, we still realize the importance of getting the children to write. So we infuse writing in the science program whenever possible, whether it's through a lab report or a log, or whether the children are just reflecting. We understand that it's important that the children write about those experiences, and they continue to do that on a daily basis.
The whole philosophy of the science curriculum is that we're trying to cultivate children who are scientifically literate and who understand the impact of science in their everyday life. The kits provide them with an opportunity to have discovery and hands-on activities so they can create their own learning.